So hello everyone. So let's discuss today's Leetcode daily challenge problem. So the given problem tells us to find the length of a subarray which has a sum greater than or equal to the given target. So yeah, let's start with the first example. So we have been given 231, 243 and a target is 7. So we can see the smallest subarray that has a sum greater than or equal to 7 is this one 43 and the length is 2. Target 4. In the second example, nums of is given as 144. So single number is enough for that is target is 11 but all number are less than 11 only. So all number sum is less than 11, that is no number exists. In this example like 1, 2, 3, 4, 5 and when target is 11 the smallest window is this one 543 of 3 length 5 plus 4 9 9 plus 3 12 and 11 is the answer for this case. So yeah, let's see the constraint. We have been given num's length as less than 1 if order. So yeah, again we know that O of n square, that is brute force solution, won't get accepted again. So yeah, recently there has been lot of emphasis has been given to sliding window concept from Leetcode in recent contests as well as last 2-3 days challenges as well. So yeah, this is again a sliding window problem. That is variable size sliding window problem. So yeah, if I won't be discussing brute force approach here because that is really easy, just do nested for loop and you can find it. uh, so let's directly start with the uh, sliding window approach. What we will be doing is, let's take the first example. 2 3 1 2 4 3. So now first I'll keep my I pointer here, my j pointer here, and I will be taking a sum variable initially as 0, and I will be expanding my window till the moment I get a sum which is greater than or equal to 7. And the moment I got the sum as greater than or equal to 7, now what I'll do is I'll try to minimize my answer by shrinking my window, that is increasing I at that time. So if we do here like initially sum will be incremented to 2, j will be moved at 3, the sum will be 5, again j will be moved to 1, the sum will be increased to 6, again j will be moved to 2, the sum will be increased to 8. Now what we see is the sum is greater than target, which is 7. So this is one of the possible answer, and the length of this window is nothing but j minus I plus 1, that is 3 minus 0 plus 1, 4. That is one of the possible answer is 4 now. Answer. So the moment I got the sum greater than or equal to 8, now I know that all the sum on the right side of it will also be greater than or equal to my target. So now I should shrink my window from left side, that is I will be incrementing I and removing calculation for I, that is I will move I here at 3. So the sum will be reduced to 6. Okay, now my sum has been become great less than my target. So I again will be incrementing j to 4. Now again my sum has become greater than my target, that is 10. So again I'll check the answer for this case. So that will be j minus I plus 1, 4 minus 1, 3 plus 1, 4, that is 4 remains, 4 only. Now since my answer is greater than target, I will shrink my window, that is I'll move I at 2 and my answer become 7. So this is the small window that I have got now, and the length of this window is j minus I plus 1, that is 4 minus 2 plus 1, that is 3 only. So I got less size window. Now I will again remove element since the sum is less equal to target, and I will increase I to 2 and I'll reduce my sum to 6. Okay, cool. Now I'll again increment j. My sum again becomes greater than my target, that is 9. And the length of this window is nothing but 5 minus 3 plus 1, that is 3 only. Okay, so I again increase I and remove calculation for I, that is 7. And now my window size become 5 minus 4, 1 plus 1, 2. That is smaller than last one, that is 3. So the answer here will be 2. That is clear. Let's discuss the second example. 1, 4, 4. Initially my I will be at 0, j will be here, sum will be initially 0. When j is increased to first position, sum becomes 1. We'll take this sum and sum become 5, which is greater than target, that is 4. So this is one of the possible answer, that is 1 minus 0 plus 1, that is 2. 2 is the length of this window. Okay, so I remove calculation for I and I will be moved at 1. J is also at 1 at as of now. So the length of this window will be 1 minus 1 plus 1, that is 1 only, because the sum is 4 and the target was also 4. So I have got min length as 1. Now I'll increase. Now I won't be now increasing, I will be again decrementing the sum, as target and sum are equal. So I'll remove this target from my sum and the sum becomes 0 now. And again I will be incrementing j here and the sum becomes again 4, which is equal to target, and the length of this window will be again incremented, which will be 1 only. So the answer here will be 1 only. So this was basically the approach. In the last example we can find that at any point of time my sum will be less than equal to target only. So I can make a check, like if at any time I didn't found any subarray sum which was greater than or equal to my target, I will be just uh, returning 0, because there is no valid subarray present. So if you see the code, we'll be applying static window concept, which is of variable size. I will be keeping a track of sum, and when the condition is hit, that is sum is greater than or equal to target, I will get one min length window and I will start shrinking my window logic, that is removing calculation for I from left side, and I will be keeping a track of minimum length window, and I will just expanding my window from j++, and at the end I will be returning minimum window. And if I didn't found any valid subarray which has a sum greater than or equal to target, I will be returning int max. So this was basically the approach for this question, and this is again of O of 1 space complexity and O of n time complexity. So and the given code is given in the description as well. And now if we see the follow-up, the question asks us to solve this question in O of n log n as well. So I can give you a hint for this. You can do binary search on answer technique. You should try this once. This is also a easier approach to do if you have understood this approach. So that's it. Thanks you.